In our digital world, we're constantly facing this tough choice when we build the systems that run, well, everything. Do we make them incredibly fast, or do we make them incredibly secure? It always feels like you just can't have both. But what if you could? Today, we're going to explore a new solution that promises exactly that. It's called ReactiveChainDB.
It's a question that has honestly stumped developers for years. I mean, think about it for a second. Your banking app needs to process thousands of transactions a second, right? But it also has to be so secure that not a single penny is ever compromised. Or a hospital's patient records. They need to be instantly available for doctors in an emergency, but they also have to be completely 100% tamper-proof. So why does it always seem like we have to sacrifice one of these for the other?
And this slide really breaks down the problem perfectly. On one side, you've got reactive microservices. These are the engines of the modern internet. They're built for pure speed and scale, which is why pretty much every major app you use relies on them. The catch? Their data isn't inherently tamper-proof. Then on the other side, you've got blockchains, which are famous for their, Fort Knox level security. But as anyone who's ever waited for a crypto transaction knows, they can create some serious performance bottlenecks. This is the fundamental dilemma we're trying to solve.
So here's how we're going to break all this down. First, we'll dive a little deeper into this digital dilemma. Then we'll introduce the new hybrid solution that's designed to solve it. We'll take a look at how it's actually built, put it to the test in a performance showdown, and finally, we'll explore what's next for this really cool technology.
Okay, first up, the digital dilemma. Let's really get into the weeds of the challenge we're up against and why it's so critical that we find a solution.
And here's the thing. It's not about choosing just one or two of these features. Modern apps, especially in critical fields like finance and healthcare, they need all of them, all at the same time. Finding a way to deliver that has been a kind of holy grail for system architects. A puzzle that, well, up until now, has pretty much remained unsolved.
So what if we could just stop choosing? What if we could build a bridge between these two separate worlds? That brings us to our next section, a new hybrid solution, and a technology that's trying to do just that.
So meet ReactiveChainDB. The entire idea here is to get the best of both worlds. It's a single, unified system that's designed from the ground up to give you the lightning-fast responsiveness of microservices, but with the unbreakable cryptographic integrity of a blockchain. So how does it actually work? Well, it's built from three key ingredients. First up, you've got BigchainDB, which acts as the secure, blockchain-powered database. This is the part that guarantees every single piece of data is immutable. Next, you have Redis, which is a super fast in-memory data store that basically acts as a quick lookup layer, giving you millisecond-level access to your information. And finally, you have Spring Web Flux, which kind of ties it all together, enabling that real-time, non-blocking data flow that makes the whole system so reactive.
So we know the ingredients. Now let's get into the recipe. How is this system actually put together? Let's take a look at the four-phase approach they used to build it.
The whole development process was broken down into four really clear phases. It all started with designing the core architecture around BigchainDB to get that security locked in. Then, they built the APIs so that other applications could easily interact with the system. The third phase was all about enabling those real-time data streams to make it reactive. And, this is crucial, the final step was creating a specialized queue to handle massive workloads without even breaking a sweat.
And that last part, that's one of the key innovations here. The best way to think about this high-throughput queue is like an incredibly smart traffic control system, but for data. It manages all the incoming requests, especially during these huge traffic spikes, and it prevents logjams by making sure every single transaction is processed efficiently and in parallel. This is what lets the system stay so responsive, even under intense pressure.
Okay, so we've got the theory, we've got the architecture, but does it actually work? This is the moment of truth. Let's get to the performance showdown. To find out, they put this system under some serious stress. The test involved firing 1,000 concurrent transactions. So imagine 1,000 people all trying to make a trade or book an appointment at the exact same second. This simulates a massive, sudden spike in activity, the kind of thing that can absolutely cripple a conventional system.
And the result? A staggering 91.3% reduction in latency compared to a traditional system. I mean, let that sink in for a second. That is not a minor improvement, that is a complete game changer. It means tasks that used to have a noticeable delay are now, for all intents and purposes, instantaneous.
And this chart just says it all. The conventional system's average response time was 589 milliseconds. That's over half a second. ReactiveChainDB, just 51 milliseconds. The visual here tells the whole story. It's an absolute night and day comparison.
But you know, it's not just about the average speed. What's maybe even more important is consistency. The analysis showed that the system wasn't just fast, it was predictably fast. Even when it was getting slammed with requests, it delivered stable performance without those wild latency spikes that plague so many other architectures.
And this chart breaks it down beautifully. You can see that an incredible 72%, almost 3/4, of all transactions were completed in under 50 milliseconds. Only a tiny fraction, just 12%, took longer than 60 milliseconds. This just shows how tightly controlled and efficient the system is at processing tasks.
Okay, the results are obviously impressive, but this is really just the beginning. The team behind this already has their eyes on the future. So what comes next for this powerful framework?
Well, the roadmap includes several really key enhancements. They're looking at things like consistent hashing, which is a smarter, more efficient way to manage data storage across a bunch of servers. They also plan to add version control, which will create these perfect, unchangeable audit trails. And they're going to use advanced design patterns like the abstract factory, which is basically a way to make the core system easily adaptable, kind of plug and play, for any industry, from finance to supply chain logistics. And that's really the key takeaway here. ReactiveChainDB isn't just some academic experiment. It's a blueprint. It's a practical guide for building the next generation of commercial applications that need to be both incredibly fast and completely trustworthy. This has massive implications for things like our healthcare records, financial ledgers, and global supply chain networks.
Which leaves us with one final, kind of provocative thought. For years, we've designed our entire digital world around this compromise between speed and security. Now that a path to having both seems possible, what new things could we build? What does a world of instant, unbreakable transactions actually look like? Now that is something to think about.